All right, let's dive right in. Today, we're going to trace the entire path of a modern AI application. We're talking from that first little spark of an idea all the way to a finished product that's live and out in the world. So let's start the journey. Look, this isn't about flashy tech demos anymore. Generative AI has officially moved past the buzzword phase. It's now creating real, measurable value for businesses. We're talking huge boosts in productivity and, yeah, serious revenue. And that's exactly why knowing how these things are actually built from top to bottom is so incredibly important right now. So that brings us to the big question, doesn't it? Let's forget all the hype for a second. What are the actual practical steps a developer needs to take to build an app that doesn't just work, but that actually wows people? Maybe even a future boss. That's the path we're going to follow. Now, you might think our journey starts with writing some code, but nope. It starts with a blueprint. This is the planning stage, and it is absolutely critical for figuring out if a project is even worth doing in the first place. You know, it's a huge misconception that the best AI projects just come from the cleverest algorithms. The real skill, the mark of a great AI architect, is being able to spot the ideas that are actually worth the effort. It's all about choosing the right problem to solve before you even think about touching a keyboard. And it really comes down to two essential checks. First, you have to define the value. That's a two-part question. Can we technically build this? And, more importantly, should we build this? Is it solving a real, painful problem for somebody? Then, second, you have to define what success actually looks like with super clear milestones. And I don't just mean technical stuff like accuracy. You've got to tie it to business goals, like user engagement or saving people time. Okay, so with our blueprint in hand, it's time to actually forge the AI's core. Think of this as heading into the workshop. We're gathering our raw materials, the data, the math, and the fundamental design. So at the very, very heart of all this is the vector. A vector is basically a numerical fingerprint for an idea. It takes something totally abstract, like the meaning of a word, and turns it into a list of numbers. This is the language computers speak. It's how they can understand and compare different concepts. So if a vector is like one single fingerprint, a matrix is just a huge collection of them. It's a big grid of numbers that organizes thousands or even millions of those vector fingerprints. This is what lets the AI see the bigger picture and do all the heavy-duty math it needs to actually learn. Now, to build that complex matrix, the AI has to learn from data. Think of it like a two-stage education. First, it gets a general education, right? It reads a massive chunk of the internet, books, all sorts of stuff, just to learn grammar, facts, and how to reason. But to become an expert, it needs specialized training. That's when you feed it a very focused diet of data, like tons of GitHub code to learn programming, or a whole library of scientific papers to become a research assistant. So how does the AI actually write a sentence? Well, a lot of the big models, like the GPT family, use something called a causal decoder. And the logic behind it is, well, it's surprisingly human. It just predicts the very next word based only on the words it has just seen. It builds out its thoughts one single piece at a time, creating a natural flow. Okay, so we've forged the core. Now it's time for school. This section is all about the active process of training the model, teaching it how to listen, how to follow instructions, and how to get better over time. A model's education basically happens in three main stages. It starts with that pre-training we talked about, where it just inhales data to learn the basics. Then comes instruction tuning. This is where we teach it to actually be a helpful assistant, to understand commands. And the final crucial step is RLHF, or reinforcement learning from human feedback. This is where real people give it feedback to make sure its answers aren't just correct, but also helpful and safe. But this brings up a huge problem. Even the best models can hallucinate. That is, they just make stuff up. Or what if you need the model to know about something super recent or about your company's private data? You can't just retrain the entire thing every time, so what do? The answer is this really clever technique called retrieval augmented generation, or RAG. It's like a little 5-step dance. When you ask a question, the system first goes and searches a private, trusted knowledge base for relevant info.
It grabs those relevant bits of text, and then it stuffs them right into your original prompt. It's basically giving the AI an open book test, saying, hey, here's everything you need to know. Now answer the question using only this information.
And this is literally what it looks like. It's a simple template, but it is so powerful. By telling the model, base your answer on this context, you dramatically reduce the chances of it making things up. It keeps the AI grounded in facts. Like I said, it's an open book test for the AI. Now, RAG is fantastic, but it's not the only trick in the book. Developers have a whole bunch of other tools for advanced tuning. They can use something called QLoRa to fine-tune a massive model on a regular computer, which is amazing. Or they use transfer learning to take a big general model and quickly teach it a new specific skill. And if they don't have enough data, they can even use data augmentation to cleverly create more of it. So we have a smart, fine-tuned model. Awesome. But right now, it's useless because it's just sitting on a laptop somewhere. Now we have to deal with the engineering side of things, how to get this thing out into the world where people can actually use it. And this is what the modern AI developer's toolkit looks like. For the core brain building, they're using libraries like PyTorch and transformers. To package it all up so it can run anywhere, that's called containerization, they use tools like FastAPI and Docker. And then finally, they use platforms like Hugging Face Spaces or RunPod to actually host the app and put it online. And here's a little pro tip right from the trenches. To make your app more stable and easier to update, you don't save the entire model. You just save its state dictionary. That's just the parameters, the things it learned. It's way more portable and way less likely to break down the road. All right, we're in the final stage of the journey. The model's built, it's in the cloud. Now it's all about showing it off and proving that it's actually good and responsible. The goal here is to build what you could call a silent salesperson, a project that does the talking for you and proves your skills. A real professional showcase isn't just a link to some code, it's the whole package. The actual working AI model, a project website that pulls everything together, an explainer video, kind of like this one, to show how it all works, a link to what you might call the project brain, maybe in Google Notebook LM where you kept all your notes, and of course, a good final report. It tells the complete story. So when it comes to judging if your model is any good, you basically have two choices, and there's a big trade-off. You can use another powerful AI to act as a judge, which is super fast and easy to scale. Or you can use human evaluators. And while humans are slow and expensive, they are still the absolute gold standard for judging true quality. And this brings us to what might be the most critical point of this whole thing, summed up perfectly here. An AI can be the smartest thing in the world, but if people can't trust it, if it isn't reliable, safe, and consistent, then it's worthless. Responsibility isn't something you tack on at the end. It has to be part of the design from day one. So there you have it. We've gone from a simple idea to a fully deployed, responsible AI application. We've seen the blueprint, the build, the training, and the final showcase. So I guess the only question left to ask is, what journey will your next AI project take?